Hi everyone, thanks for joining in. My name is Shubham. Welcome to Reset. Uh, just wait a few more seconds, more people can join in. Or okay, so I'll talk about myself. Uh, my name is Shubham. I'm a student at UBC. I'm doing my bachelor's in computer science. But then I've been doing tutoring in maths and physics basically for a while now, and this is what I like. And again, Reset as well, like we are a platform which excels, which helps excel the students in their field.
Could you tell me more about Reset and how you came to work at Reset?
Yeah, again, I've been doing tutoring like one-to-one for a while, but I just found out about Reset a few months back, and then I really liked you know the platform itself. The institute, the place is really nice, and uh, the people here are super friendly, super helpful. That's another great thing. And the environment itself is really nice. And then they really do care for student. And then it's not just about the business, but about helping people, and that's something which I really liked. And that's why. And then I joined, and I've been liking it so far. Let's keep. Okay, so let's start. So we're gonna be talking about pre-calculus today. As you already know, most of you already know, we're gonna be talking, what is pre-calculus, why do we need it, and then, what are the basic concepts to just help build a strong foundation, which you're gonna be, most likely be needing in the future courses. So let's get started. All right, so what is pre-calculus? So again, the term defines, the term itself, defines it's something we do before calculus. It's a course that prepares students for calculus, covers basic concepts in algebra, trigonometry, and also introduces functions, equations, and inequalities, which is what we're gonna be talking about in this session. Again, it's a bridge between the algebra and the complex topics, which which we're gonna be seeing more in future courses, such as like Calc 1, Calc 2, and all that. And even like we're gonna be needing this in uh, not just maths, but physics and all these courses. Um, and then obviously we do have topics like limits, derivatives, and integral. So to help to help better understand it, we do need to take this course, and then also it helps problem solving and analytical skills, which we do need for the advanced mathematics. Okay, so goals for today, we'll be talking, as I said, we'll be talking to help us understand functions, how to solve equations, and then also just kind of introducing what inequalities are and how do you graph it and all. And then our objectives, obviously, we do want to be more comfortable with the core pre-calculus concepts. Uh, Obviously, basics of functions, equations, and inequalities, and just building confidence in reasoning and problem solving. Let's go ahead. Okay, so introduction to function. So as most of you already might have heard about this term, so what function is, it's a relation between a set of inputs and a set of possible outputs, where each input is directly related to exactly one output. So that means it's basically, a relation, as it says. We have multiple sets of inputs. We plug in an input and we get an output. Expressed at f of x, you might have already seen this notation where x is the input and f of x is the output. So this is how we usually graph it. For example, we have this function which is like, f of x. That's how we read it. Function of x, or we sometimes say y. Y is your this vertical axis, and x is gonna be your horizontal axis. So 3x plus 2. So for example, we wanna find the function value at x equals 2. So what we're gonna do, we'll substitute x equals 2 in this original equation, and then we do the math and we get 7. So that means when x equals 2, f of x or y equals 7, and then we can see in the graph, so this is x equals 2, and then we get y equals 7. And then this is how we actually draw the graph. We plot multiple points and then we just join it. In this case, it's a linear equation. We're gonna be quickly seeing that in a moment as well. What is a linear equation? But this is a line, and then this is how we do it. So we plot multiple points and we just join them. And in this case, we, as I said already, we get a line. Again, it's visualized as a graph on coordinate plane. So I already talked about it. It's with x-axis representing the input, which is your horizontal axis, and then y-axis representing the output, which is your vertical axis. Again, it's not standard, but this is what you would see most of the time. You can always switch it, but it's all most like 99% of the times you would always see like this is your x-axis and this is your y-axis. And again, you can see like maybe once in a while you might say, okay, this is x-axis and this might be y-axis, but this is how it usually is. Okay, let's move ahead. So types of functions. So there's multiple functions. This is just two examples. We can have like infinite number, but again, this is something basic you're gonna be seeing in the in the very beginning. So linear function is something which we just saw. It's a line, basically, as the name suggests. So this is the simplest type of function of the form mx plus b, where m is the slope and then b is the y-intercept. So slope, what slope is basically, it's basically is a rise over run. So that means how fast is the y changing when, or if your how fast is the y changing in regard to your x. So for example, if my x increases from 2 to 3, how much my y changes. So that's gonna be your slope, especially in this linear function. So that's gonna be for your entire, so it's gonna be uniform, and then this is what we see in the linear functions. That's your slope, and then y-intercept is basically the value where x equals 0. So at the origin, so this point, the 0 and 0, so right in the middle, that's called origin. So when your x value is 0, your b is the y-intercept. So for example, let's take this example. So fx equals 2x plus 1. So that means your slope here is 2. So that means, so when your x changes by 1 unit, your y changes by 2 units. So y is growing as twice as fast as x. And then 1 is basically just the value when x equals 0. So when x equals 0, when you plug x equals 0 here, you get f of 0 is just 1. So this is your point. So that's why you see, the line starts here. So this is why it's called y-intercept. It means when your x is 0, what's the function value at that point. So this is the linear function. We'll talk about quadratic. Again, these are just two. We're gonna be seeing a lot more, like they're gonna be logarithms, exponential, even like polynomial in general, like cubic, and just more in future. But this is something, again, as I said, we're gonna be seeing a lot more often in the beginning. This is functions which involves usually x squared term, and then they have the graph looks like a parabola. This is called a parabola, the shape. It's like a U shape, and then it's usually gonna be x squared minus, or like it's gonna be always this form, a x squared plus b x plus c. Again, this is called basically degree. So in this case, the degree of this equation or function is 1. There's nothing, so we assume there's a 1 here. So power of 1. So that's what we call degree. And then this is degree 2. So that's how we tell it's a quadratic equation. Again, as I talked already, this is called parabola, and then this is a U-shaped graph. And again, there's a way to graphing this function. And then let's talk about that as well in more detail. Okay, so let's talk about properties of function. How do we define a function? What are the basics that we need to know to tell if you know if an equation, or if a statement, if it's a function or no? So domain is all the possible input values for the function. So that means all the values which we can plug in the function so that our output is a real number. So I'm sure you might have already heard about real numbers. um, so for example, let me take this example, and then let me talk about range as well quickly. Range is all the possible output values. So domain is basically all the possible x values, and range is all the possible y values. So all the possible inputs that you can plug in the function, it's gonna be your domain, and then all the values you will get um, from all those values of x would be your range. So let's take this example. So we have a function square root of x. Again, so for square root of x, the domain is x. So this is how we read it: x greater than or equals 0, which means we cannot put any negative values. And why is that? Because if we do put negative values inside a square root, we don't get a real number as an output. So that's why whenever we have a square root function, the domain is always x equals or x greater than or equals 0. That means x cannot be negative. So that's how we tell what the domain is. And again, the range as well, since you're gonna be always getting positive numbers, so hence your range. So this is the function basically. This is the graph of that function. So see, we don't have any negative values. We cannot basically. So that's why we are only starting here. So the graph is starting right, and it's only applicable for all the positive values of x. And then range as well, because we are gonna be only having positive values. So hence we only have this, all the values which are positive and above 0. And again, one more thing to check if it's a function or not, we do a vertical line test. You might have heard already about this. But then if the graph, like let's say if we have a graph and then we do not, we do not know if it's a function or no. So that's how we do like a vertical line test to make sure if it's a function or not. If it passes, that means if your line, like at any given point, if it passes the function more than once. So for example, like let's say I had this uh, I had a function which is like a something like this. So this parabola, think of it as, it's already extending this side. So in that case, if I draw a vertical line, it's gonna it's gonna pass the graph twice. So that means we have two possible outputs for one possible input, which is not possible. So for example, in that case, we only should have, since this is the x-axis, we cannot have more than two values for f of x or for y. So that's why it has to pass the vertical line test, and this is the best way to check if the given graph, if it's a function or not. So yeah, checks if a graph represent a function. If a vertical line crosses the graph more than once, it is not a function. All right, let's go ahead. Let's talk about equations. So again, slightly more, like it's another way of writing functions. But then this helps us, uh, know more about the function itself, what are the domains. Again, graphing, as I talked a little while earlier. So function equation. So equation is like really simple definition. It's a statement where two expressions are equal. So pretty straightforward. Again, so linear equation. Again, we talked about linear functions and quadratic functions. So this is just again, as I said, it helps us understand the functions better. So again, this is the equation of the form ax plus b. So same as linear function, but we do equate to some number. Usually it's zero or could be any number. Like for example, you have another number here. Again, then this is just a way of representing a linear equation where a and b are constants. So, and then solution is found by isolating x. So for example, let's take an example. We have this equation, 2x plus 5 equals 13. Again, this is basic algebra and we want to solve, for x. So how do we do it? We just, we subtract 5 on both sides to get to get the 5 cancelled. And then we are left with 8 on the right hand side. So we'll have 2x equals 8. And then again, dividing by 2 on both sides give us x equals 4. So basically x equals 4. So if the meaning of this solution is if we get x equals 4, and then if we substitute in this equation, then the left hand side should match the right hand side. So let's take that as well. So 2 times 4, which is 8, plus 5, which is 13. So that makes sense, right? So this is what we do when we want to solve for x. Okay, and then quadratic equations. So same way, we have x squared term. So there's linear are much simpler, but quadratics are slightly different. We have multiple ways of solving quadratic equations. One of them is factoring. So for example, we have this x squared minus 4x plus 4 equals 0. So there's times we can use factoring. We can factor out all the possible values of x, and then that helps us get the solution. Or there's another way, which is quadratic formula. But then again, that's slightly trickier, but it's something which we can use when we are not able to factor. So I'm not sure if you've done factoring before, but there's a multiple ways again. We want to see the product. So let's say if we have ax squared plus bx plus c. So we want to look at two numbers whose product is a times c. So for example, in this case, a is 1 and c is 4. So, product of a and c in this case is just 4. So 1 times 4. And then b is gonna be the sum. So b is in this case is 4 or negative 4. So you want to look at two numbers whose sum is 4 and then product is 4 as well. And then obviously we get just one possibility in that case, which is 2 times 2. So 2 and 2. So their sum is 4 and their product is 4 as well. So this is one way of factoring. Again, as we go along, we do this in more detail. X minus 2 and then x minus 2 is 0, and then we get just one solution in this case. Again, we can have multiple in this case. Let's say it could be like x minus 2, x minus 1. That's fine as well. So in that case, we get two possible solutions. So again, same thing. So if the solution means if we do plug this back in the original equation, we do get 0. We should get 0. So let's try that. So 2, okay, so 2 square is just 4. 4 minus, this is 4 times 2, which is 8. So 4 minus 8 plus 4. Yeah, so it is 0. So this is how we can kind of verify, if our answer is correct or not. All right. Okay. So yeah, let's talk about inequalities. So we did go through over functions and equations briefly. Again, those are very basic ones. As I said, we're gonna be having a lot more complex one as we go along, and then involving trigonometry, logarithms, and all that. But this is just to help you understand what really function in and what exactly we are doing and why we are doing it. And then inequalities would be something which you're gonna be seeing as well. So basically, it's slightly same as equations, but as the name suggests, it's exactly opposite as well. Inequality compares two expressions and shows if one is greater or less or equal under certain conditions. So this is what you're gonna be seeing. Again, you might have already seen these symbols before. Less than, greater than, this is less than or equal to, and then this is greater than or equal to. So the difference between less than or equal to is just, so let's say we have two expressions and we have this sign. So then that means strictly, for example, this case, x is less than 2. So that means x cannot be 2. It has to be strictly less than 2. But if we had this in symbol instead, greater than, or sorry, less than or equal to. So in that case, x obviously is less than 2, but it can also be 2. So in that's the only difference when we have, this equals to sign here. Again, we have, so we're gonna be doing linear. Quadratic are slightly not trickier, but it's slightly different than linear, but we're gonna be talking only about linear in this case. So inequalities that involves linear expressions are pretty straightforward. Such as, let's take this example, 2x plus 3 less than 7. Okay, so same way, we're gonna be solving this exactly the same way as we did equations. So, we'll subtract 3 on both sides, we get 2x, so this cancels out and we get 7 minus 3, which is 4. So 2x is less than 4, and then simplifying this, we get x less than 2. So basically just dividing both sides by 2, we get x less than 2. And then again, how do you graph it? So inequalities can be graphed on number lines. So, so this is what we call a number line. So we just have one horizontal line and we have all the possible values of x. So for example, this one, x less than 2, it's represented as an open circle at 2 with shading to the left. So shading, that means, so this is just basically a way of representing the possible values of x which will satisfy this inequality. Right, let's take an example. So for example, x equals 0, which is within this range. So 2 times 0 is just 0 through 3 less than 7, which does make sense. So that's why any values less than 2 will always satisfy this equation. And then again, the only difference between equation and inequality is an equation you only get like a finite number of values which will satisfy your equation. But inequality, you will usually get a range of numbers. So in this case, you have your solution as x less than 2. So x can be any number less than 2. It can be 1.3, it can be a negative number, it can be 0, like anything, up to which we call negative infinity, which is like a really small or negative number. If we keep going on, and then, all those negative numbers will satisfy this equation. And then just another thing I want to point out is having an open circle. So open circle means, again, as I was just talking a while ago, the difference between these two symbols. So this means strictly less than, and this means less than or equals to. So in this case, x is less than 2 or strictly less than 2. We won't be including 2. That's why we have an open circle. But then if it was, let's say, x less than or equal to 2, we would have put a closed circle. So you would have like a solid dot here. So that means x can also be 2, and then any number less than 2. So in that case, let's say if it was, less than or equal to, so in that case, we would have, even if we had x equals 2, so 2 times 2 is 4 plus 3, 7. So yeah, in that case, we would have still the equation satisfied. But in this case, we cannot have 2, because that makes this expression 7. So you would have 7 less than 7, which is not true. So hence we have an open circle, and hence we do not include 2 in this case. Okay. Okay, so quick recap about what we did in this session. We talked about function. How do you, understand it? How do you recognize, what are the possible values of x, what are the possible value of y, which are called domain and range. And then how do you graph a function? So again, I did briefly go through what are the ways of graphing a function. Basically we plot few points, and then that's one way of just connecting those points. So let's say we do just plug in 3 or 4 values of x, and we got their corresponding y, and then we just plot those points on the graph, and then we just connect it, and then that's most of the times we are able to graph the functions, especially linear and quadratic. Again, equations, how do you, what are linear and quadratic, how do you solve it? We did go through that. And obviously inequalities, so how do you solve it, and how do you graph it? So we only went through linear. As I said, we also would have a multiple, you know ways of having inequalities involving quadratic equations, a even more complex function. But then this was just like a way of just kind of introducing what it means, and how do you solve it. And yeah, and then obviously we would want you to just kind of practice more on, you know these topics, to just make sure your base is strong, and then this is always gonna help you understand your topics much more, you know in a better way. All right. Let's so okay, so I'll wait if somebody has questions. So yeah, obviously, if you can always come back to this video, and then, if you have still some doubts, you can always ask, you can just email it to this email address, and then we'll get back to you as well. Um, okay, that's pretty much it. Obviously, get your participation certificate. We do encourage you to just go through this link and then kind of register so that you get your participation certificate for joining today. All right, thanks for joining in. Um, yep, thanks for joining. Hope to see you soon. And then everybody have a good day.